Welcome to the lesson on isosceles triangles. First thing I want to start with is refreshing our memory. What is an isosceles triangle? So first thing we need to look at, an isosceles triangle is a triangle that has two congruent sides. Those two congruent sides are called your legs, and then the non-congruent side is called your base. Along with the base, we have two base angles. What we learned today is that those base angles are congruent. So if you have two congruent sides in a triangle, then you have two congruent angles. The angle that is not congruent then is called your vertex angle. So we're going to try a few problems practicing that. Give me a minute to click on this. And we're going to practice looking at what sides would be congruent, what angles would be congruent from the information that we're given in some diagrams. So here we have triangle DEF, and it tells me DE is congruent to DF. We want to name two congruent angles. So what you need to look at is what sides are congruent. And what I have people do is picture it that we're used to our two congruent sides point up. So if we picture it that those two congruent sides point up, then I'm looking at the two angles that would be on bottom are the ones that are congruent. So that would tell me then that angle F is congruent to angle E. So from these two congruent sides, again, we picture it turn, so my two congruent sides will be pointing up, and the two base angles are congruent. And then it goes through the solution here. Our next one here tells me two congruent sides, and I want the two congruent angles. So when we have a figure that has many different sides here, what I suggest is let's highlight the two sides that are congruent. So we have HG and HK. So what that means is we're looking at triangle HGK. So these are my two congruent sides. They're pointing up. That means my two bottom angles here would be my two congruent angles. So in this case, we would have angle G is congruent to, well, we can name it angle K, but there's a couple of different angle K's, so let's use our three letters. It should be HKG. And that would be the correct answer for that one. So now we're going to practice that they give us a couple of congruent angles, and we need to name the congruent sides. So in this case, let's go ahead and mark those two congruent angles. We have KHJ. So KHJ would be the angle here. And then KJH. So KJH would be the angle there. And we need to picture in our mind, if we turn that triangle so those two angles will be on bottom, what two sides would be pointing up? Well, we would be looking at this side, and this side here would be pointing up. So then I know side HK would be congruent to side KJ. And that would be it for those examples. So now what I'm going to do is real quick go on and get to the next example. So now we're going to be talking about the actual measures of some of these angles, knowing that two angles are congruent and then one angle is not. Just to refresh your memory that the angles in a triangle add up to be 180 degrees, and that's going to be what helps me here. So we want to find the value of x and y in the diagram. So if we're looking here, we have the y here, and we have all three angles marked congruent. So if all three angles are marked congruent, that means that I have an equiangular triangle. Well, if it's equiangular, that means it's also equilateral, which would make all three sides of this triangle the same measure. So since that's 4, that means this one would have to be 4, and that one 4 as well. So I automatically know that y equals 4. Then the next thing, I only have two angles marked congruent in that triangle, so that means I have two congruent sides instead of all three congruent sides. Since these are already on the bottom, I know my two congruent sides would be the side there, and the side there, because those would be the sides pointing up. So since they're congruent, my equation would be x plus 1 equals 4. Then I just solve my equation. So it would be x equals 3. Okay, the last thing we're looking here, this lifeguard tower, if you can read up here, we have PS, which is our side here. So here's PS. There's a P up here and an S down there. Is congruent to QR. So here's Q and here's R. And it also tells me angle QPS. So QPS, this whole angle here, is congruent to PQR, which is that whole angle there. And wants to know what congruence postulate can you use to prove that triangle QPS is congruent to triangle PQR. Now we do need to be careful on this because we do have overlapping triangles. So QPS would be the triangle here, and then PQR would be this triangle here. These have a different sort of shared side. We of course have these two sides are congruent, so that's a side, and these two angles are congruent. But they also share this side on top here of PQ. So we need to mark that as a side, and that would tell us that they are congruent by side angle side. Then it tells me, well, why is PQT isosceles? So if we're looking at PQT here, why is it isosceles? Well, we can look at and we're just going to go ahead and get out of this. And here are a couple of problems that I want you to look at. I know we haven't worked a whole lot with angle measure on here, but you need to keep in mind that up here we have 54 degrees. If here are my two congruent sides, I'm looking for X is here, and then Y is there. So here's X and here's Y. I want to find those measurements. So you need to keep in mind what angles would be congruent. And also here we want to look at what legs are congruent in each of these triangles. So those will be a couple of questions I want you to take a look at.